Hello, in this example we want to take a look at how to make a number line using mean and standard deviation and look at the dispersion of data based on that mean and standard deviation. So what I'd like you to do first is take the apple data and place it into L1 and the banana data place in L2 and sort your data. If you need to pause the video, do so now. Okay. In the apple data for L1, I asked what N was. If you look at your list there, you'll see you have 23 data points. For banana, we have 25. So they're similar in size. And this spot down here at the end, that's just blank. Do not type in a 0. There's nothing in there. Okay. For this example, we have to calculate first the standard deviation for each data set because I'm asking you which scores are more variable. So we want to see which data set has a higher standard deviation. Also for this example, I'd like you to look at when you do one var stats to calculate the standard deviation. Let's use population standard deviation for this example. So the one that says sigma sub x, it looks like a little sigma x. Do not use, okay, there's the other one is sx for sample. Let's don't use that one this time. Let's try population standard deviation. Okay, so if you enter one var stats, L1, you will find the population standard deviation for apple to be 13.8. The population standard deviation for banana should be real close to 14.7 if you round. Okay. And again, beside that value, you'll see Sx equals 15. Okay, I'm just choosing for us this time to try it with population data. Okay, so the population data. This Sx over here, 14.2, you may have seen that. That's the sample standard deviation for the apple data set. Okay, continuing on down. Calculate the mean for both classes. Okay, so in this one, we're doing the mean. So looking at your one var stats, that's your X bar. So the one var stat X bar for apple, 73. The X bar for banana, we have a 77. Okay, so next up, show on a graph what the dispersion of test scores looks like about the mean. Okay, make two graphs, one for apple, one for banana. All right, great. So we want to take this, start with your mean value close to the center. First one I'm going to do is apple. Okay, so I'm going to be using these values over here. Mean is at 73. I'll mark a little X bar. And then I want to add 13.8 going to the right so that we can get 3 deviations to the right. So if I add, we'll have here 86.8. That's 1 deviation. Add again, 100.6, 2 deviations. And then 114.4, 3 deviations to the right. Now if we subtract that standard deviation of 13.8, so 1 deviation to the left is going to put us at 59.2. Subtract again, so we're at 2 deviations, 45.4. And then we are 3 deviations to the left at 31.6. Okay. Then if you take your data from your apple, okay, so we're doing apple, okay, we will take that and place it in the appropriate position on your graph. Okay, so something you could do if you have your data sorted, we can go down through here. This is kind of what I did. I just went through the list and I said, okay, here's a value, here's a value, here's a value, and I just kind of marked them in there. I don't have mine sorted right here, so maybe you can go through and check, but I have 5 values in this first section, or in the first compartment, from 45.4 to 59.2. From 59.2 to 73, I also have 5. Okay, and I'm just pulling those values from your calculator. We have 8 numbers in the next compartment. And lastly, from 86 to 100, I have 4 values marked in there. Okay, so that was for the apple data. Okay, now if I do a similar thing with the banana, we will start over here with a mean of 77. Okay, and then we will do, change colors. We're going to do 3 deviations to the right, 3 deviations to the left, just like on the apple example. So this time I'm going to be adding and subtracting 14.7. Okay, so the values going to the right should come out 91.7, 106.4, 121.1. Okay, so they have 1 deviation, 2 deviations, 3 deviations. Okay, then we have, coming backwards here, 62.3 if I'm subtracting, 47.6, and lastly 32.9. So this is 1 deviation left, 2 deviations to the left, and 3 deviations to the left. Okay, so another way to handle this marking of the data, I used just little X's in the first example. The other way you can do it is actually take your data from your calculator and write it in the compartment. So from 47.6 to 62.3, on my calculator, I see I have a number of 50. So I could say, okay, it's in this zone right here. All right, I could keep going through my list. I have a 53, a 53, a 55, a couple 61s in that first compartment. In the next compartment over, I start at 66. And again, I'm just reading from the list on my calculator and I'm putting in the values where they would belong. 74, I have a couple 76s, actually 3 76s. Okay, coming on over, we have a 79, 2 of those, a couple 82s, an 84 and an 87. Okay, next up we have a 92, 3 of those, a couple 95s, 97, and another 97. Okay, so that should be the placement of all values. Okay, so now the next thing up on our to-do list here, it says calculate the percent of scores within 1, 2, and 3 deviations of the mean. Okay, so in fact, why don't I take us down here to do that? Okay, so again, let's start with apple. Within 1 deviation of the mean. Okay, well, let's see, up here at the top we wrote down that we have 23 numbers. Okay, so out of 23 numbers, how many of those values happened within 1 deviation of the mean? Okay, so we have 8, 9, 10, 11, 12. Looks like we have 13 there. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 13 values, looks like. All right, so we've got 13 out of 23 values there. And let's see here. Bet you've got that on your calculator already. 13 out of 23. How about around 56? I don't want that color. 56.5%. Okay. Within 2 deviations of the mean, let's see what we've got here. So from here to here, oh, well, look at that. We've got all values, so that's 23 out of 23, or 100%. And then finally, if we just to record it to answer the whole question, 23 out of 23 is still true because there's nothing else there. We have all the data. Okay, so while I'm here, why don't we just put the banana data right beside it. All right, so within 1 deviation of the mean, we have, let's see here, from here to here, 2, 4, 6, 8, 10, 12. It looks like we have 12 values in there. out of, how many data points do we have? Banana had 25. All right, so we're 12 out of 25. So that should come out around 48%. Okay, within 2 deviations of the mean. Got a little problem here with my writing. So 2 deviations of the mean. Let's see, this time we are from here to here. So 2 deviations. Oh, well, look at that. This one worked the same. 25 out of 25, or 100%. Okay, so then it follows that within 3 deviations of the mean, we're still at all data in 100%. Okay, so this apple banana data is experimental. It was observed, okay, and these are the percentage that just happened to work out within 1, 2, and 3 deviations of the mean based on our calculated mean and standard deviation that we created the number lines from. Okay, so the last question on here is, what should the percents be? Okay, what should they be, meaning what do we expect them to be based on theory? Well, the empirical rule tells us that we should expect within 1 deviation of the mean, 68%. So in both of our experimental data, we're a little bit low. Within 2 deviations of the mean, we can expect 95% of the data. Well, we were a little high on that in our actual calculations. And within 3 deviations of the mean, we expect 99.7% of the data to show up. Well, and we were already at 100. So that took care of that. Okay. So this was just a nice example to show you observed data, how it can plot out on a number line according to the mean and the standard deviation, so then that we can calculate percents in the different regions and compare it to the theoretical rule for what we expect to happen in those different 1, 2, and 3 deviations from the mean, and we can do a comparison. Okay, hope this was helpful for you, and you all have a great day. Thanks for watching.